Hey guys, welcome. Yeah, so another fun problem on the infinite geometric series. And this time what we have to do is compute the value of this infinite sum. Yeah? Okay, cool. Now, before we can apply the infinite geometric series formula, we have to manipulate the given expression. So let's work on that. First, notice that I could split it into two fractions. What's inside of sigma here? I can split into two fractions like this. And then I could, in the first fraction, write in the numerator 2 times 2 to the power n minus 1. And why I like that is because the 2 to the power n minus 1 in the numerator now, and the 3 to the power n minus 1 the denominator can be written to a common power as soon as I take this 2 here in front of sigma, right? And before I do that, before I take that 2 in front of sigma, I want to split it into two different sums. So I'm allowed to do that. That's a property of sigma that allows me to do that. By the way, I have lots of videos on sigma and its properties, so check those out if you're confused about any of what I just showed you. But yeah, by the fact that we can take a constant in front of sigma, I'm going to take this 2 and write it in front of the first sigma, and that way I could do this. And that is, once this 2 in the first sigma is written outside, then we'll have 2 to the power n minus 1 divided by 3 to the power n minus 1. That's the same as 2 divided by 3 to the power n minus 1. And then in the second sigma, in the numerator, the 1 can be written to the power n minus 1 because 1 to the power n minus 1 is still 1. And once you put a power n minus 1 on this 1 here, then you could write 1 to the power n minus 1 divided by 3 to the power n minus 1 is 1 over 3 to the power n minus 1. Okay, cool. Now, setting aside this 2 in front of sigma, what we have here is an infinite geometric series. And likewise, behind the subtraction sign here, what we have is an infinite geometric series. The maroon infinite geometric series starts with the first term 1, because if n is equal to 1, then we get 2 divided by 3 to the power 1 minus 1. So that's 2 divided by 3 to the power 0, so that's 1. So we'll get the first term being 1, and clearly r, what we're multiplying by, is 2/3, and also we note that r is an absolute value less than 1, so we can use the infinite geometric series formula. And here, and what's in blue beyond the minus sign, the first term is also 1, because if n is equal to 1, we get 1 divided by 3 to the power 1 minus 1, so that's 1 divided by 3 to the power 0, which is 1. And r this time is 1 divided by 3. So summarizing everything I just said is like basically writing this first, setting aside this 2 here, and using the infinite geometric series formula, where a, the first term here, is 1 and r is 2/3. And so applying that, we see that this infinite sum here in maroon is going to be equal to 3. And of course, we shouldn't forget to multiply by the 2 that we took in front of sigma. But yeah, the maroon sigma here is equal to 3, we just saw. Now, working on the blue sigma has first term 1, as I already said, and r is 1/3. So plugging those in to the infinite geometric series formula, we see that the blue sigma has value 3/2. And therefore, our series, which is the same, the original series we're given, which is the same as this here, is going to be 2 times 3 minus 3 over 2. That is 9 divided by 2. Yeah? Cool. All right. So we took what appeared to be a very difficult task and made it simple thanks to the infinite geometric series formula. Right? Okay. All right. Many more videos on the infinite geometric series to come, and I hope you enjoyed this one. Keep watching. Take care.